Good evening, everyone. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, sir. Okay. So today it is our second day and third session of our FDP. And in this session, we have Mr. Priyachandan Satpathy with us. He is an accomplished academician and researcher currently serving as a head of the department of Electronics and Telecommunication Engineering at the Aryan Institute of Engineering and Technology, Bhubaneswar. He holds an MTech degree from the Indian Institute of Technology, Kharagpur, which is one of the premier institutions of India. Mr. Satpathy has made notable contributions to research and innovation with patent granted in both the United Kingdom and India. His academic and professional interest encompassed communication system, signal processing, LSI design, embedded system, and artificial intelligence application in electronics and communication engineering. With a strong passion for teaching and technological advancement, he has guided several students' projects and research initiative aimed at bridging the gap between academia and industry. Under his leadership, the EC department at AIET continue to promote excellence in education, research, and innovation. So please welcome our Sir Mr. Priyachandan Satpathy to deliver his speech. Please, sir.
Good evening to all of you. My video is audible to all. So first of all, hello everyone. My voice is audible to all.
Yes, sir. Yes, it's audible.
Okay.
Yes, sir.
First of all, I will congratulate and thank you all the participants for your support or for your attendance. We have joined heartfully. Whole attendance is there. Everyone eager to know about this Atal online faculty development program, next generation aerial communication, integrating AI and drone technology. As a departmental, EC departmental faculty, I have chosen this topic and in collaboration with our Kaushik Mahanti sir, our first resource person. He is the man who encouraged us to go for this drone technology as a online Atal FDP. So today I am giving as a research person, my topic will be 5G or 6G integration with the drone for high-speed communication system. Before going to your slide, all of you, we are going for this basic contents, and this is our basic communication point of view. When we are starting, all of you know we are going from a generation wise. Today's world, generally, if you go for nowadays, it is a Gen Z like system. But what we have studied, it is our 1G, 2G, 3G, 4G, 5G, 6G like that. So when initially we are going for the communication, simply a man-to-man voice communication analog type. The analog communication we are going for, and it is a very like a voice calling system and having very small data bit, 2.4 kilobits per second, and in the early 1980s. And it is the era where device here is diode. Simply that through the diode we are doing all the electronic devices. So next when is the evolution start in 90s, is the digital voice system is start. And in that case, we have brought here digital signal. And simply we can send text message. If you can remember in your Pushpa movie, we have a MMS system like a pager. So is that area will be start from that. In the 2G right now, it is also we are using that 2G model. In your village, you can find all the farmers or any lower category peoples, they are having that 2G system. So simply a calling and a text message. In that we can go up to maximum up to 64 kbps. Next is the most significant we have done in a revolutionized mobile internet speed up to 2 Mbps in a 3G. I remember in your early 2008-9, BSNL first started that 3G system, and we have having a free video calling system. BSNL provide that, not all other provider, mobile provider that not given, only BSNL is given. So we are going for that video calling and enable our web browsing. So mobile broadband also in that area, it will be there. It is a high speed data internet access we have getting. Next year, the scientists or the researchers, they found that the 4G is better than the 3G model, and they have found that it is the long-term evolution. That's why its name is LTE. In early 2010, it was evolved, and we are going for that standardization one 3GPP. That is a mobile standard is in the 3G further area, further whatever the evolution is going on. And 4G, they found that it is the last one. We are not going further beyond it. The maximum we can send up to 100 Mbps to 1 Gbps. We are doing a high definition streaming, video conference, real time that applications. Whatever we are doing is very massive broadband and IoT. We are still now and continuing. The maximum 99% of the mobile provider are in 4G. Right now, BSNL is doing that 4G system. They have implemented the 4G antenna. But now, in recent 2020, we have again found out some device, sensor, and system-based that is digital and a massive broadband with IoT. It is a 5G system. It is better than 100 times better than the 4G, and we are getting a 10 Gbps, gigabit per second. In that area, we can connect that drone or drone as a mobile base station. We will be going the further one. Now we are going a new technology that is a 6G. Before I am going to 6G, I can give a things that recently China have developed. So 5G, they can connect the satellite communication system only through the 5G, not like any other communication. And in 6G, they have found that in Japan it is already implemented, and they are going for a 4K, 8K video conference streaming system. Support your augmented reality, virtual reality application. Still it is going on in 4G and 5G, but in 6G it will be more possible because of the speed. It is 100 times faster than 5G, 1 TB per terabit per second. So this leap in speed will support the next generation technology like holographic communication. As you know, holographic means I am present here. My image, a holographic image will be there. All of you are seeing in the movies. Recently, movies there, Houseful 5 or something. You can see that holographic image will be showing on. In Hollywood, we are seeing that all these things. So here is the immersive extensive reality and quantum computing also you can do in your 6G. So this is the evolution of data transmission. This is the basic of your 5G architecture. Previously in 2G GSM mobile system for mobile, in 3G, 4G, we are doing for the BSc, MSc base station, home location register, VLR, digital location register, all these things we can go for in 5G architecture. Simply we are going for the implementation from network function. And all are the network slice section, network slice section function, NSSF. And the network expose function, NEF. The network read positive function, NRF. And the policy control function, PCF. The unified data management, UDM. The application function, AF. The authentication server function, USF. Another is the access and mobile ID management function, AMF. The session management function, SMF. The use plane function, and one is your data network, the radio access network, and the user equipment. From the user equipment, the radio access network, then you can go for the use plane function. In the context, we can go for the most important component. You can find out this is the AMF and the RAN and the EV. Generally, the AMF is responsible for registration and connectivity management, as well as the managing on reachability of the UV. And the support mobility of 5G network, you can go for maximum up to 500 km per hour or maybe 100 km per hour. For supporting that, if you are going for 6G, the handling node mobility is enabled by this network function. Generally, the RAN utilize the radio transceiver G node, GNB, that facilitates cellular connectivity, and GNB provides generally new radio NR user plane. You can in your 5G phone, if you search, there is a things is there NR. Like you're in VoLT, voice over LT. In your LT phone, 4G phone, you can find it is a VoLT, voice over LT. Similarly, in your 5G phone, if you search it is a NR is given, new radio. That will be control the plane protocol interface with UE. In general, this is the simple architecture of 5G. And if you're going to, what is the impact of 5G on my drone connectivity? Generally, if you're going for in the 5 years ago, the drones were still kind of a toy-like thing. We are going for the capture any photo, video. This way we are doing this. Some park-wise we are going for some, not a big part of your connectivity. But when you are faster the Wi-Fi from the LTE, then we are going for the some different thing like your agriculture, defense. We are using that 5G. In industry operator, cities, we are going for this way. We are using the 5G. This is the one way that drone with camera. We are having some cellular drone performance, photo taking, any video, any sensor based some data we are collecting through the antenna. We are going for a storage data process. Then your live interface we are taking. Any you can see in your like your any detail led in any parties or any like that in dance band. This way functions you are watching. But in general, when you are going for the low, ultra low latency, that when your device will be faster, traditional don't demand something lag. They will be lagged. When you are real time performance, they are having the lag. But in 5G, it will be only you can latency going to up to 1 millisecond. In millisecond, you are getting the data, more and more data. That means the operator or AI system tells a drone to turn, drive, or however, when you inbuild that into AI, all these things will be happening. In a real world, if you go for, you can go for the disaster monitoring, military mission. Every second that will be matter because in 1 millisecond, some disaster can be happen. Or any military session in second wise, something will be changes. So that latency will be matter. So how we will be going for that? The smooth streaming of high resolution of data. 5G is not about the faster flight. It is also about master decision making. With real-time 4K video transmission, thermal imaging, sensor feedback, operator on the ground get crystal clear visual and instant data. If you are going for what is the fundamentals, if you go, these are the applications: inspecting bridge, wind turbines, pipelines, monitoring crop health, covering live events, managing urban traffic. Not just visual, we are going for the analyzing cloud data like that. But the capability of 5G is what? It is about the groundwork of drone integration, which will be a significant role. How? When you go for the ultra low latency, the previous slide I told you. You have the high bandwidth. If you high bandwidth, then whatever the 4K video you have find out, or thermal imaging, or any elided data, all that will be remote monitoring, and you can go for the surveillance. Or then only it will be a reliable connectivity. That 5G allow the creation of dedicated virtual network that provide communication to ensure stable and consistent performance. We can go for the edge computing, the processing data close to the drone network's edge. That will be reduce the delays. When you are going for the edge computing, it will be reducing the delays, enable onboard AI algorithms. Another is just small capabilities. In the last evening, Kosis had told, number of drone can at a time they will be communicate each other. This is because of the low latency that allows coordinating the multiple drone in a small, it is a complex collaborative mission. So as I told, multiple drones, one mission they can do. You can go for the going beyond the horizon. That delivers drone in a remote or rural areas, border and coastal patrol operation like that. This is the one scenario, how the terrestrial network coverage enhancement will be drawn, and drone will be acted as a base station support for firefighting scenario. If you are going for that, from a base station to drone, that signal will be going, then from drone to that firefighting scenario, they will be providing that signal. So you can do the first drone enable base station scenario, that only revolves around the terrestrial circular network enhancement. And if you going for the aerial node function, the cellular base station can provide ultra dense small cell network, that type, which are highlighted in the 5G or 6G. You can go for, but in a short-term line of sight link among the your user, the coverage and capacity of the wireless network can be effectively enhanced. The next generation communication, if you go, it will be support your MIMO based, multiple input, multiple output. In that, you can entirely new and a dynamic reconfigurable enhanced cellular network you can found. Here is the example is given. When you have on-demand terrestrial network coverage, capacity enhancement, if you need, then you can go for this session. And it will here show that a possible application is on-demand terrestrial network coverage enhancement in the case of wildfire. Here it is what a line of sight between the radio and the corresponding UVs that associated with the end user in need. And temporarily deploying a drone base station helps that the issue by introducing a new path. Thereby, you can establish a temporary yet direct and reliable link between the end user and the cellular infrastructure. Because from the antenna point of view and the firefighting scenario, there are some buildings, houses, maybe, but some hills are there. So all you know that due to the spark loss or that scattering effect, diffraction, signal will be not going to that get. All the signal is not get. The quality of the signal we cannot get. So through drone we can cover it. Another scenario is there, a drone-based station assisted vehicular communication scenario. How we can give the vehicle to the proper signal through the drone, and drain from the another region through the plane also we can give the signals. Directly from the antenna point of view, we cannot give signals to the moving vehicles. So we can give through the drone or through the plane. That deployment is generally a UAV type, UAV or SWAN UAV, that diverse the environment present challenge in decision making, control, or path planning, communication, monitoring, and many more. Also here the safety will be most important, because the signal safety, privacy, security, or here the power, all are the significant concern. And safety risk rises from the lack of GPS alert or and privacy issue related to data collection. Security risks include generally your signal data hijack may be possible. So and power related channel will be there also. Power related channels involve longer flight times. If you have longer flight times, then also it will be a problem. And the need of standardization, and there is also a wireless sensor limitation is there. Maybe its performance, resource allocation, regulatory, you have to change the power constraint, that to be addressed. And if you go to the privacy, safety, or environmental concern, then we are going for the different drone perspective or UAV perspective. That will be categorized. So further, when you are going for the airborne base station, this offer a new terrestrial confinement spectrum of diverse networking opportunity to boost reliability and last mile connectivity in the network at hand. An intelligent approach to accommodating mobile ad hoc networking is the clustering of ground UV instances into mobile span. This can be implemented to enable drone base station to potentially communicate with a singular network UV instance, functioning as a dependent or a cluster head. Like our, if you communications guys are there, you can know our cluster head, how we are doing the frequency reuse. This way we can use it. The cluster head is responsible for distributing message by broadcasting, and the connectivity of mobile terrestrial ad hoc network can be significantly improved by adopting cluster head and unique mobility characteristic of the drone. And as is the case with the terrestrial network enhancement, we have had a scenario that drone will significantly increase the quality and reliability of their offered service by considering efficient placement and swarm node relative positioning where applicable. Next, another is here like a swarm system, multiple drones in one mission. Multiple drone will be giving you some different signal at sometimes multiple drone at once without signal crashes. This drone will be specially used for surveillance over wide zones, coordinate agriculture pairing, multi-angle film shoots. Recently, I have got a news that through the drone, maybe at Rajasthan, we have done this that rain system. The first time, maybe sorry, not Rajasthan, in Delhi. Indian government first implement this through the drone. We are going for the rain system. This is one type of example. And we have gone for the emergency coverage over large disaster areas. Each drone stays connected and streams its own feed and communicated in real time. It's like a Wi-Fi mesh networking. As we are in the college or in offices, we are doing the Wi-Fi that type. Also, 5G in some other action will be there, like smart farming. The drone can scan the soil, identify pests, and track water level. With 5G, this data synchronized to dashboard instantly, letting farmer take the real-time action and reduce reduce wastage. Emergency response we can use, whether it's a forest fire or flood, earthquake. The drone can now eyes in the sky. That they provide live updates to first responder, helping them find survivor, then plan and rescue routes. Industrial inspection also there. The companies are piloting generally 5G powered drone deliveries in both urban and remote locations. From groceries to medicine, these deliveries are fast, trackable, less affected by traffic. You can listen some news about that. Maybe Flipkart or in Partner they have used through the drone. They are getting that groceries or in medicine in some case. That delivery and logistic, in oil rigs, construction site, factories. The drone with 5G are replacing risky human inspection. They capture real-time videos, scan for defects, or they even relay thermal imaging. All these things you can draw through the 5G. This is one of the case of what is the role of AI. AI, as you know, as a brain of the drone, it can act. As AI powers real-time drone decision, the drone can take the decision. They can choose their path. They can choose their which way the signal can go. They can take a decision. They can reduce their power. They can use which type of sensor we can use. When it will be maybe the audio will be recording or the video will be recording. When it will be off, on. All these things through this it can do, and it will be done through the onboard chip and the cloud dependency. And then it will be 5G connected drone to cloud dashboard to taking all the data, maybe sensor data, whatever the video recording, all these things data will be recorded, and then it will be encrypted data ensured that will be transmissible. So this way AI will be going. When you're going to be edge AI, the drones are now equipped with onboard AI chips which allow real-time decision making, cloud connection as I told you, data transparency, ethics, with stricter privacy rules. Drones are being used to clearly communicate how data is collected, stored, used. That 5G enables encrypted, that traceable data flows, making drone operation more accountability and trustworthy. Another is your mobile fast command centers. Thanks to improvement of a mobile UX UI, many drones platforms are now allow full flight control by smartphone or tablet. This is done without compromising safety and decision. Next, it is all about the 5G. So what you do, despite all these advantages, 5G has some limitation also. That is one is maybe going for the infrastructure challenge. You have to investment so many infrastructure, like you can see BSNL could not afford that 5G. In 1 to 6 cities they have the 5G because you have to going for that infrastructure, particularly the development of the new cell tower, which is reliance on high frequency band. In 5G, we have gone for 12 band, 13 band, 14 band, number of bands are there. So it is a infrastructure challenge will be there. And also limited global coverage. 5G rollout have primarily focused on urban areas, leaving rural and remote region. Also power consumption is there. Energy efficiency you have to improve. The massive increase in the number of devices also connected, that network present power consumption challenge will be there. Another is non-zero latency, and you got the ultra high HD image. If you go for the 6G, so you can get some more thing. 6G could bring latency which is below 0.1 millisecond. In 5G, we are going about 1 millisecond. It will be 10 times faster, making drones reaction faster than ever. That pair that with 8K real-time streaming, and drone could become airborne AR or VR camera. Satellite integrated connectivity. One of the most exciting things about 6G is that it will combine terrestrial and satellite network. That means drone will stay connected even in jungles, ocean, or war zones. So we cannot rely on the antenna. With the cell tower, 6G can take from the satellite, they can take the signal. This is the 6G evolved. The first time 6G will be submitted at March 2019 to identify the key challenge and its vision towards 6G will be summarized in a statement: ubiquitous wireless intelligence. Anywhere, anytime, that time. The AI will be foundation of that 6G evolution, which allows self-managing, intelligent, and adaptive wireless network. Unmanned aerial vehicle like your drone and a terahertz communication and intelligent reconfigurable surface are among the most promising technology during that 6G evolution. The EAB-enabled network will extend coverage in both disconnected and mobile setting, providing flexible on-demand communications for application related to disaster relief, autonomous mobility, and industrial automation. This is one type of 6G architecture. 6G architecture you have to define in every area, as it will ubiquitous in space, in area, in air, in land, in sea and undersea. If you go for the space wise, so it's like a satellite constellation. So one potential aspect you can go for 6G architecture in space deployment of satellites. So satellite it consists of 100 or even thousands of small satellites, as you can find in number of satellites are there. All will be provided to get a global coverage, and each satellite could communicate with user devices on Earth or other spacecraft, forming a complex network that enables seamless communication. They will be taking the decision where to connect and what to connect. In your Hollywood movies, you can see that we have America will be always have some they have that capability to look after the India what are doing, Pakistan what are doing. This way they will be in a film you can check. Right now it will be possible in 6G, and also there is the inter-satellite communication. Satellite they can communicate. So the 6G might involve high advanced inter-satellite communication will be, that capability will be possible. And that way you can exchange the data directly with each other. Another case is their orbital diversity. Different orbit such as a low Earth orbit, medium Earth orbit, then geostationary orbit could be leveraged to provide a mix of coverage, capacity, and latency. The LEU, that low Earth orbit satellite, can offer low latency but require more satellite for global coverage. While the geostationary orbit, that will provide wide coverage, but it will be higher latency. Some delay will be there. Generally, GEO satellite are giving delays, LEO will be in a faster way. But in that way, you have to provide the advanced antenna technology. That 6G could introduce more advanced antenna, such as your phase array antenna, enable dynamic and adaptive beamforming. And this could allow satellite to focus their signal on specific areas or devices, improving signal quality, reducing interface. Also, when you are going for the layer wise, there is a layer optimization. To meet that space environment, cross layer optimization could play a role, which involve in coordinating communication protocol, network architecture, that physical layer technology. You have to ensure that the efficient and the reliable communication. If you're going for the satellite communication way, then you have to go for the energy efficiency and power management. 6G architecture would need to incorporate energy efficient design to prolong operational life of satellite and minimize the need of frequent management. When you're going for management, again we're going for the security concern. That should be a security concern. It should be reliable. The space-based communication system would need robust security mechanism to protect against potential threats. As you know, from country to country, it may be there is a security concern will be there. If you going for the 6G architecture in air, it is below that satellite. Air means your airborne or drone, UAV in that area. That area we are going for. So here we need what? The flight connectivity. Flight, they can connectivity is there. It should be ultra fast because flight will be moving way. The 6G could offer even more faster and more reliable connectivity for airplanes, allowing passenger to enjoy high definition streaming, virtual reality, and real-time communication during flight. I maybe listened news that maybe I don't remember. Some flight will be there allowing Wi-Fi system, Wi-Fi things, Wi-Fi signal you can access. Generally, in your flight you cannot switch on your phone, but right now some airlines they have given some Wi-Fi system, and maybe this in 6G you will be generally overall connection will be there, faster connection, and it will be enhance your aircraft communication also. Since 6G will be low latency and high bandwidth will be there, it will lead to efficient and secure communication between aircraft and air traffic control. And in your architecture of 6G in air mode, also you have to go for the surveillance, navigation, like 6G enabled sensor and communication system would be enhanced aircraft navigation and surveillance, enabling better tracking and coordination of aircraft even in remote area or in challenging environment. Another is their aircraft to aircraft communication. 6G could facilitate direct communication between nearby aircraft, enhancing collaborative decision making, avoiding collision in congested airspace. There will be predictive maintenance will be there. Some sensor will be advanced sensor you have to need, which will be connected in real time monitoring the aircraft system components, allowing for predictive maintenance to prevent unexpected failure. You know, recent we have gone for different plane crash will be there. So we have a black box is there, but black box will be given you the after the incident will be over, what are the reason. But if you can find out the real time scenarios, some sensor will be there, advanced sensor, in 6G it will be possible. Because real time data collection, then processing, that will be, as I told you, in a millisecond, everything can be happen. So in 6G, it will be possible. We can have some real-time sensor-based data monitoring. Next year, emergency response, search or rescue system in high-speed 6G connectivity would improve communication during emergencies, aiding quicker response time, enhancing coordination in search and rescue operation. And another is the passenger service also you can give. 6G might support your advanced automation within the aircraft cabin, improving passenger service, optimizing cabin operation through the real-time data. Another is your secure communication. 6G potential advance in encryption security could enhance the protection of critical aviation data and communication. If you're going for the land point of view, in 6G architecture in land, what type of architecture if you define? Already generally antenna, a cell tower, and your mobile or in car in your vehicle communication, this type. So here we need what? High frequency. because we have your number of subscribers there. In that case, we need a high frequency, high bandwidth. Uh, just as with your new generation wireless communication, we have to provide a high frequency to accommodate increasing data rate or capacity. This could use up the microwave, millimeter wave we are generally calling, and potentially it is the terahertz. The terahertz frequency we have to use in your 6G. And since it is a massive massive multiple input, multiple output MIMO system, and 6G will be expected to continue the trend of using that MIMO antenna. And advanced beamforming technique to improve spectral efficiency, coverage, and capacity. Ultra dense network also, there is a concern increasing number of connected devices. 6G might employ ultra dense network employment. Their small cells and access points are densely packed in urban areas to provide seamless connectivity. If you can use in generally in our Baliyatra event or in any type of event where number of persons are there, maybe 10,000 or 1 lakh near about, we can find the network connectivity generally zero. That is called a dense area. In a small area, when number of subscribers there, we cannot have that network or signal. In 6G, we can avoid that dense network. We have the supply. Next is the AI and network intelligence. In your machine learning, they will play significant role in 6G. It could be used for dynamic resource allocation, interface management. Then going for the undersea. In the general, it is not undersea. We are having that a optical communication or your underwater communication. The underwater communication present generally radio frequency of signal, high attenuation, which will be absorb that signals. So acoustic communication is commonly used in underwater, and it will be having your 6G architecture. You have to involve a combination of acoustic and optical communication using visible or maybe in near infrared light, possible the electromagnetic communication using very low frequency. When you are going for the acoustic communication, the underwater acoustic communication involves sending and receiving signal through sound waves. It can support relatively low data rate, but can cover a longer distance. And 6G architecture might include advanced technique for encoding, modulation, and error correction to improve data rates and reliability. Acoustic communication generally, the dolphins are having that sound, sonar sound, this type. Also, you have the optical communication, and that using light waves could be explored in high data rates over the shorter distance in clear water. However, optical signals are susceptible. Sensor network and IoT, this will be a undersea architecture could involve deploying sensor network for various applications such as environmental monitoring, underwater exploration, disaster prevention, resource management. And these networks could be part of the border of 6G ecosystem. Another reason for latency reliability. If you going for underwater, also there will be some latency and reliability are the crucial factor, because in a remote operation of underwater vehicle or monitoring critical infrastructure, the 6G architecture should prioritize low latency and reliable communication. Environmental impact. The impact of new communication technology on underwater ecosystem must be considered. That minimize the interface with marine life and preserving the water environment essential. Last maybe 2-3 years below, there will be, you can have there is a incident, we have lost some people due to some submarines will be failure. We can have, if I got that real-time data through that underwater, in 6G it will be possible. So we can save that life. These are the architecture we can go for. So what are the advancement in 6G? If you're going for your augmented or virtual reality, using a VR set, all you have right now a VR set, we are doing for the 3D image or 3D video. People can make the eye contact, interact with a virtual object. This is the best example. If anybody can watch the film Iron Man or any Hollywood film, there is a helmet will be there. In Iron Man, that through that helmet you can real-time data you can see. So many real-time data that maybe one what is called anyone's information. Once it is see somebody, he will be detailing so that this man, this age, he is having this type of maybe job or what is the capability of that. Any object or human body in any house or in colony, every route, GPS location will be there. If you can see in that film, in Iron Man helmet, it will be everything will be given you that. Every information is available here. This is the augmented reality. Virtually a physical physical world will be virtually in my eye. Right now, maybe I don't remember what Google will be having. A Google Glass will be there. It will be providing everything. Everything in that glass you will be seeing. So it will be replace your mobile phone recently. Next is your holographic telepresence. That is a 3D holographic. As I told you, a holographic image will be standing here. If I am talking to you, let you imagine that in your laptop you only were seeing a 2D video or 2D image like that. But if you imagine that in your room, I will be in your room like in a holographic image. My image will be there. If you put your hand, nothing will be there. It is air. But you are having a holographic image will be produced. This will be possible in our 6G, smart healthcare. 5G we are deploying some sensor-based technology, but in 6G it will be more real time. It will be possible. Maybe in a like it is called what some robot-like things that medicine will be going to into the blood. They will be identify the cancer cells. They can damage it. So it may be possible. Everything will be in real time. Its data will be collected. Then it will be possible. Industrial automation 5.0. We are all in the industry 4.0. But right now, the 6th generation will bring industry 5.0. Revolution to some digital transformation of manufacturing process using cyber physical system or IoT services. Like if you electronics engineer, all electronics lecture, they will be found that in VLSI, you are doing the chip is only found by the robots. Robots will be doing that chip fabrication. We are only giving the design. But in general industry, all we are doing that industry, your automation is there, but we are doing through the some command point of view. But if you think that machine will be automatically doing everything, no human will be required. In that case, in 6G, it may be possible. There is some specification and requirement. You need a massive connectivity, reliability, latency, ubiquitous connectivity, anywhere, anytime, anywhere. You have to security, unmanned mobility will be there, that drone system. So in 6G, you have to that privacy, security, that sustainability, hardware design, power consumption, spectrum constraint. All these things will be need. Every part we have some different issue will be there. In privacy, some issue will be there. Security, you have some issue will be there. Sustainability, in hardware design, you have to know high hardware design. Power consumption also is there. If you going for the real-time data, you have to use the power, but you cannot provide that much power to the device. You have to consume that much power. So power should be reduced. The spectrum constant will be there. Spectrum constant means you cannot have that bandwidth. For different cases, different bandwidth will be need. If you go for the key parameter of 4G, 5G, 6G, if you compare, so already 6G have some higher standard. If you're going for the carrier bandwidth, in 4G it is only 20 megahertz. In 20 megahertz, we are going for the bandwidth will be given to every subscriber. Actually, your operator, maybe Jio, maybe your Airtel, whatever. In 5G, it will be given 400 megahertz. In 6G, it is about 100 gigahertz. In terahertz, there will be going to communication. Bandwidth is what? They are higher to lower frequencies. Peak data rate will be in 4G 1 gigabit per second. In 5G it is your 10 to 20. In 6G it is your terabit. Latency is your 100 millisecond. In 5G, as I told you, 1 millisecond near about. In 6G it is your 10 times faster in microsecond. Mobility in 4G you can cover up to 350 kilometer. In 5G, it is your 500. In 6G, it is your 1000. Reliable system is, reliable is 4G will be 99.99, but 5G it is somehow higher, 99.999. In 6G, it is near about 100. Just reduce 0.00001. Connectivity density, 4G you cannot have that density of connectivity. But in 5G, you can go for 10 to the power 6 devices per kilometer of area. As I told you, in a function or in general in a Baliyatra or in any large crowd, some announcement will be there. Some right now, maybe in South, some incident will be there. When a large number of crowd will be there, so number of devices you cannot connect in 4G. 5G it is possible, in 6G it is more devices will be possible. When you go for the security concern, it is a medium in 4G and 5G, but in 6G it is very, very high. User experience, this is your more things will be there. User experience, as a mobile user or a drone user or any electronics user, when you getting the signal as per my use, that is more concern. It is in 4G it is 10 megabits, but in 5G it is 100, 6G it is 10 Gbps. Already in Japan, they have found that in 6G, maybe I do not remember the accurate timing, but in 1 second or maybe in very small time, they downloaded all the Netflix content. How fast this is. So, now the requirements. As I already told you, some carrier bandwidth you need near about terahertz. Frequency up to 10 gigahertz in millimeter wave band. Spectral efficiency. You need spectral efficiency must be 5 times higher than 5G. Peak data rate, that will be 6G in greater than 1 terabit per second. Mobility, its maximum speed will be 1000 kilometer per hour. Energy efficiency, latency, all these things will be requirement. What is the 6G network technology will be there? The technology wise, if you go for, you need a supermassive MIMO, artificial intelligence, terahertz and visible light band, Internet of everything. Internet thing will be there. Nowadays, my Internet of everything. Blockchain, intelligent reflecting surface, intelligent editing, digital twin, and a robot avatar, zero trust network, like that. Zero trust network means generally you can find without network we can communicate. Recently, news will be there in maybe Nigeria, Ghana, I don't remember, but in Nigeria maybe there will be one student will be invented a mobile without any network you can call. Recently, maybe BSN will be involved in a case. If you have only Wi-Fi system, you can call to anyone. You no need of any cellular network. Without that cellular network, you can having that communication. So, as you go for the drone system wise, the unmanned vehicle, aerial vehicle, we are exploring all these things as a base station. Generally, we are using signal or 5G, 6G, whatever the signal we are calling. Your drone will be act as a base station that can be relocated to improve the network coverage capacity, quality of user experience, that feature and specification available market. UAV जो भी हमारे पास है available in the market, we have to use that. UAV is applicable in the 6G era. UAV for cellular coverage, precision agriculture, surveillance. UAV enabled edge computing. UAV assisted backscatter communication. These are the challenges UAV having. If you employed or deployed in your 6G, you have that privacy, safety risks, decision making. How you have to take the decision using that AI. What is the control over your path planning, power constraint, and all the resource allocations. All these things will be going in the terahertz communication. We are going. Main feature or specification of terahertz is what? High directionality and security. One is a allows line of sight propagation, resilience to weather condition, low ambient noise, and health safety. Generally, the high demand of mobile data traffic. When we're going rapidly, we need that multiple tens of gigabits per second. It raises a concern about having enough available spectrum to meet these demands. You need that whenever the more number of subscribers there, consumer will be there. How you will be giving that frequency? That achieving spectral efficiency of tens of bits per second or hertz is challenging under practical constraint. So only option is to increase the availability of bandwidth to several tens of gigahertz. So it is not feasible generally identify such a large amount of spectrum in regulating the band below 300 gigahertz. So you have to meet the increasing traffic demand for wireless data or millimeter wave. As a system from 30 to 100 gigahertz radio frequency band, it is become an indisciplinable tool for indoor and outdoor wireless communication. The microwave technology exploits the large and unused spectrum in the millimeter wave band, resulting in higher bandwidth. Another is a standardized effect in terahertz communication. You have some standardized rule. Anybody cannot use any type of signal. So you have to go for a standard one. So the terahertz communication band has the following feature that make preferable for some communication situation or application. As I told in the World Radio Communication Conference or Spectrum Management Framework, coordination for 6G integration. This like you have to give a standardization. As in a general way, you can find that in our TV communication, mobile communication, satellite communication, maybe in Wi-Fi, Bluetooth, all having different frequency range will be there. So there is some standard will be there. That standard you have to follow. When you go for the application of terahertz communication, it is the ultra high speed wireless data transfer. Generally, it will be various application you can find out, which will be depending upon our demand, our different domain. Which will be enable maybe a cellular hotspot providing high throughput to connectivity or densely populated area, terabit campus private network coverage, low latency connectivity. You need a high resolution imaging or sensing, terahertz IoT, industrial automation, biomedical application, in quantum communication support. In generally also terahertz communication can support also industry 4.0. Maybe in internet application, the terahertz communication generally it will be in link between the close proximity, facilitating device to device connection. Generally, security. If you go for the security point of view, it will be having a spectrum technique which will be challenging to address. There are some challenges will be there like your path loss, absorption, limited communication range, complex hardware requirement, power consumption, energy efficiency, interface management, all this integration with your 6G ecosystem, all these things will be challenging for this terahertz communication. We can go for the multi-hub relaying in terahertz network, reducing path loss effect by breaking the communication link into shorter segment. You can use that. Initially, we are doing that drone. In between, some drone will be there. It will be path loss will be not there. You can go for the shorter segment. Number of drone you can use. Overcoming molecular absorption peaks since relay can be strategically positioned to help signal bypass in the high absorption frequencies. Multi-hub relay can greatly increase the communication range, making terahertz technology more applicable in real-world scenario. Shortening the distance between nodes improves signal reception, which lowers bit error rate and boosts overall link robustness. And we can use this swarm drone, that multiple drone, they will be communicating with each other. Last evening, the Kaushik sir shows how they will be implemented using that swarm drone. It will be enhance the connectivity, coverage, number of drone will be there. Directly from the antenna, drone will be act as a base station. They will be giving you signal. So it will be, coverage will be more, connectivity will be more. Dynamic disaster monitoring they can do. Transformative application we can do. Energy efficiency also. Very less number of energy will be needed. Integration of the 6G technology. If you some drone will be there, 6G technology integration. We are doing that terahertz communication, AIML use, integrated sensing and communication we can use, blockchain will be used, edge computing used to handle management also we can do in a swarm drone. Also there is some opportunity in 6G agriculture. That drone swarm technology for plant seeds, identify disease outbreak by surveillance large areas, deploy treatment such as fertilizer to crops, emergency management. Responder could use drone swarm to find missing person or any delivery of emergency care supplies during natural disaster. Drone swarm could also help firefighting track, control the spread of wildfires, collect information about damage access point. All this is same thing in your 5G in 6G. Same way drone can be used, but it is having a some faster way. Since latency will be less, more data can be real time will be it will be there captured. Entertainment, this is the most thing you need. Entertainment organize you can do number of drone to entertain you, like a firework. You can have some pollution, fire disturbances to animals or humans. It may be there, but entertainment point of view, you can see in recent maybe Aiet, remember they will be deploying some drone to show the that how Diwali will be celebrated or how one serum structure. So in air or in skies, they have different entertainment point of view. They have shown number of drone will be there. If you remember or anybody watched that film, I can remember. Maybe that is Spider-Man work from home or something is there. In that way, everything will be a water monster is there. A, what sand monster is there, but all are in a drone structure. Drone will be making that water monster. They will be giving that image or that light. It is a drone way it will be showing. If you watch that film, you can easily find out how span drone will be there. Now we have to conclude it. The advanced 5G and emerging 6G wireless communication technique represent a transformative shift in global connectivity landscape. EAB provides flexible and adaptive communication solution in remote or dynamic environment. Whereas communication overcomes bandwidth limitation to support ultra high data rate. If you're going for the future point of view, you have to development the intelligence resource algorithm and hardware feasibility, standardized framework. What are the challenges and future outlook? If you're going for one is your energy efficiency. You have to power consumption of the devices will be there. That is a constant for drone, especially when you're going for the high performance 6G hardware. So you have to go for the solution like energy efficient protocol, AI based power management, and reserved drone are under development. Scalability, interoperability, standardizing protocols for dense drone traffic and ensuring seamless interoperability between terrestrial, aerial, and satellite network is crucial for widespread adoption. Network security, the interconnected nature of 6G drone networks creates new vulnerabilities to cyber threats. Advanced security measures like blockchain, quantum cryptography will be necessary. Regulatory framework, authorities like FA needs to establish clear regulation for the safe and reliable operation of drone, especially autonomous and beyond visual line of sight flights. Thank you. Thank you all. Hello. Somebody have given some question. I couldn't, my voice is audible or not? At high mobility, what kind of
Audible, sir, audible.
Yes, yes. In communication, when we are going for the 5 km per second, that is it. Generally the Doppler shift will be there. I remember. Maybe Doppler shift, your handover or your beam alignment. This type of thing will be there. Physically, if you go for maybe your that kinetic energy, maybe it will be affected. Hitting or some that type of force will be there. I'm not going for that detail. Generally, Doppler shift will be maybe that effect will be there. Okay, thank you for all. Thank you for listening.
Thank you, sir. Thank you very much for your such inspiration and informative talk. Your words have given a lot of things about and learn from. So, dear participants, our second session will start at 8 p.m. today. So, within that period, please give your attendance, and feedback form is also shared to you. So, please fill up the feedback form and give your attendance. We will get back at 8 p.m. Thank you.
Small announcement. Please wait. Maybe 7:45 our research person will be available. Before 15 minutes, all of you can join. 7:45. The sharp time we will be start, and the attendance and regarding this feedback, I will be sharing. I will be sharing the link in this chat box. And all of you listen. This is one time you can enter the attendance or feedback. So no need to send in a number of times, and all need to be present session wise as a whole session, because in a 10-second, 10 minute, 20 minute, we cannot give you the attendance, or this FDP is not for that way. So I am sharing all of you, just 1 minute. In group I am sharing that. All of you can take that in your WhatsApp group. Chat box also I am sharing, don't worry. Through chat box also I am sharing that sessions feedback and all that. Just a minute. So here I am sharing your feedback on attendance. All of you can give one time, and this form will be only countable up to 7:45. So all need to join at 7:45. After 7:45, this link will be, we are not recording any entry after that. So thank you for the session. We will meet at 7:45. Thank you all.